Okay, I guess now I am live. Guys. Okay, so if I'm just live now, let me welcome you all again. Guys, I Abhinav Negi welcome you all in the faculty driven platform that is Resultant. In this video, I will be telling about stress concentration, not going into the PhD of stress concentration because particularly for civil engineering, directly a numerical about stress concentration is not asked, but for interview point of view, for understanding the concept point of view, we should be knowing about the stress concentration. Okay, so quickly confirm me once again, guys. Audio, video is fine, everything is fine. Okay, let me hear in my mobile. Yeah, if in my mobile is fine, I'm 100% sure it will be fine in yours as well. Let us take this plate. Okay, let it be a metal plate or any material plate. Now in this plate, suppose I am applying a P force. I am applying a P force here. Guys, if I am applying P force only here, it will accelerate. No stress will be coming. Stress will not be coming, guys. It will be only accelerating. So of course, guys, now if I apply a P force like this, now acceleration will be 0 because net force is 0, and now the stresses will be coming. Okay, so guys, this is the P force. If only one P force, it will be accelerating, guys. Acceleration will be force, that is P by mass, and stress will be 0. Now here also if P is coming, in this case, guys, stress will be something, we'll calculate it, and acceleration will be 0. Now what will be the stress? At any section, suppose this is a section, what is the stress? So we normally say that stress is force by area. Actually this force is internal force. Okay, internal force by area, stress is this normal stress. Okay, and we assume, see the word, we assume that stress is constant, and for this whole section the stress we write out down like this, it is a constant. So I should be making a straight line, it is like this. Okay, for tension, because I am applying a tensile force, so it will be like this, and this magnitude is P by A. This is the stress, and we assume at all the section stress is P by A. But guys, to be very practical with you, at the point where the load is applied, of course at those molecules, those atoms, the stress will be more, and the point which is here, which is farther from the point of application, stresses will be less. Guys, if I apply, everyone please see, if I apply a P here, okay, and suppose this area is A and applying a P, okay, so the stress is P by A, but theoretically, exam point of view, we assume that all over my body the stress is P by A, but actually the point where I am applying the load, those molecules are more stressed. So here the stress will be more, and at this point stress will be less. Okay, but theoretically or in the questions we assume that stress is P by A. Everyone got it? Okay, so we assume that it is P by A. Actually at this point stress is more. This is what we do, and this you have to do in the examination as well. Now what is stress concentration? Suppose the same plate, same force we are applying, P and P here. Okay, and suppose I want to calculate the normal stress. At this section. Okay, suppose the net area of this section is A net. Okay, this A net means this area subtracting this whole. The whole is here. I have subtracted this area. So this and this area is A net. Now what we will be writing? The same thing you have to write in the exam as well. Okay, the same thing you have to write exam as well. The stress at this section, let this section name be XX. The stress at XX is given by force, internal force, by net area. This you have to do in the examination. Theoretically we do it. Theoretically it is correct. Okay, this is what we have to do in the exam. In the exam we have to do like this. But what actually stresses? In actual, guys, if I apply the load like this, now here the discontinuity is there. This is the hole. There the stress will be more, and very obvious. This is called stress concentration. This is called stress concentration. And obviously, guys, see, when load is coming now, at this point, the load is coming now. So all around 360 degree, the molecules are there where it can transfer the load. All around 360 degree, this molecule has the capacity to transfer the load. But this point, it can transfer the load only at half the points as compared to this. So this molecule will be more stress. This molecule will be more stress because it cannot transfer the load as this molecule is. So here is the stress concentration, guys. Here is the stress concentration. Let me tell you example. Suppose this is a metal plate. And I make a hole. I am doing this live, guys. If you are watching this video in 2027, 2028, let me tell you, this is a live video. Might be my experiment may be wrong, and after some time some funny clips will be coming on this experiment. Okay, this is not a recorded video, so I can't retake. Okay, so let us assume Ijjat bach jaye, Bhagwan kare. Now this is, guys, I am making a plate like this. This is a plate. You can take this of any material, and suppose this is a plate. I am applying a P load. Guys, theoretically, the load everywhere should be P by A net. Okay, constant. P by A net constant. This is constant load. This is constant. This is theoretically. But practically, I told you that at discontinuity, the stresses will be more. Now, if I apply the load now, then which point it should tear off first? At these discontinuous points. Because here the stress will be more. Theoretically, everywhere stress is P by A net. But practically, if I apply the load, it should be tearing off from this position, not from here, not from here, not from this section, not from this section. It should be coming from here because here there is stress concentration. Yes, you can see. Yes, you can see. See, it is coming from this section. Okay, guys, I have not made any earlier adjustment. Like the heroes are taking the beer bottle like this and beer bottle is breaking because that bottle is already broke. I am doing everything live. Randomly, guys. Randomly I am taking this paper. Okay. Now, everything is fine, guys. Everything is fine. Nothing adjustment. Again in this paper, guys, I am making a hole. This is live video, guys. This is a live video. Okay. Theoretically, everywhere the stress will be P by A net. But actually, at the point discontinuous, there will be more stress. That is stress concentration. Now, again, I apply the load. It will not fail from here. It will not fail from here. It will fail from here because of more stress due to stress concentration. Okay, this is stress concentration, guys. And because of the same concept, have you seen the aeroplane windows? Okay, the aeroplane windows are like this. Let me tell you, 1950s, 1940s, the aeroplane window was something like a rectangular, and there are not 1, 2, 3, many incidents have taken place. Then suddenly in the air, the aeroplane window has broke up and some passengers were hit like anything. They were seriously injured, including few deaths also. Why? Because, guys, here is discontinuity. At these edges, it is discontinuity. They are not as smooth as here. Here the stress can be transferred to all the points. But at those discontinuity, the molecules are not as available at the center point to resist the load. So at these points, the stress will be more, stress concentration. Discontinuity should not be there. So at oval shape, guys, oval shape also the same thing. This point can absorb the load in all points, but not this. But discontinuity is less as compared to rectangular. The curvature is not changing any point, which is changing here. It is smooth. It is continuous curvature. So here, guys, comparative to this, less stress concentration. Therefore, nowadays in all windows, it is like this, windows are not like this. Same concept, the oil tankers. Guys, the oil tankers, you have seen, the oil is not like this. Okay, the truck is like this and the oil tanker is like this. Okay, so that the curve shape is helping to reduce the stress concentration. At these points, the stress concentration will be more, leakage chances are more. In containers, normal containers, for transporting the almiras, for transporting the sofas, anything, this is fine. But for oil, where the pressure can be more, where the leakage is more dangerous. Guys, if in a truck there is sofa, there is almirah, leakage will not do anything. Sofa will be there as it is. But in containers like this, okay, the which is carrying oil or crude oil or petrol, if there is any discontinuity, if there is any hole, the whole oil will spill out. So again, the curvature is like this, stress concentration should not be there. Okay, I hope guys you enjoyed this video. Please let me know in the comment section how you like this video. You can also join me in my Telegram group, Civil by Abhinav Sir. Already more than 6,200 students have joined here, guys. You can also connect me on my mobile number, okay, or my email ID as well for any doubt. Okay, similarly for mechanical, you can connect at these numbers. These are our faculty members. You can join us on Instagram and Facebook as well. You can download the app from the Play Store. You can write down the Resultant Civil if you are a civil engineer, or you can write down the Resultant Mechanical if you are a mechanical engineer. You can go to the Play Store and download these apps and enjoy our courses. Thank you guys. I hope you take benefit from this video. This will be helping you for understanding the various concepts. Okay. Thank you. Thank you all. Take care.